Nice. All right, now we are. So, so the other day, as I said, I made that video about combinations and permutations and counting principle, and so hopefully you've watched it. If you haven't seen it yet, just go watch that sometime today. But we're going to talk about it a little bit more, and the idea that you have, I don't know. Well, for instance, here's a classic. How many different two-kid families can you have? Well, you can have a boy or not a boy, boy or not a boy. So you have two chances on each child you have. So if you had a 4-kid family, that'd be 2 times 2 times 2. Why did I write it again? 2 times 2 times 4. You'd have 16 different possible 2-kid families, if you will. So you could do something like this. You could do, you could do the whole all boys routine. And then you could go all the way through, and eventually you'd end up with the all girls routine over here, right? And then, of course, somewhere along the line, you could list them all out. I don't know why I chose 4 kids, but I did it, so I'm committed. I'm going this route. I don't care. Now, remember, what I'm doing here is listing out the sample space. But in reality, I don't really need to list the sample space. I just need to know how many are in the sample space. That's the whole point of when we talk about what's called combinatorics, which is combinations, permutations, the counting principles. The idea of how many different outcomes are there. Because remember, probability is just an amount of outcomes divided by an amount of outcomes. That's all it is. And so I just need to know how many are up here and how many are down here. That's the whole point of this. I don't need, in other words, to list out the entire sample space. That said, I'm going to go ahead and do it on this one. And so what I want, and what kind of reason I want to do that is because I want you to see in a few minutes when we start looking at combinations some more, where am I getting these numbers like 6 or 4 or whatever it is I'm getting? Where are those numbers coming from? Am I just making them up? And the answer is no, I'm not just making them up, most likely anyways. Did I get him yet? I don't think I got that one yet. I think I was missing one. Nice. And there's the 6 that should be there. And then of course there should be boy, girl, girl, girl. No. This is harder than it looks. There we go. No. There you go. And if you count those, there should be 16 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 outcomes, which is exactly as promised. Okay. Now, when we look at these, there are 4 kids, and if I choose, I say I choose, the good Lord chooses, fate chooses, whatever, that none of them will be girls. No girls, let's say. Well, 4 choose 0. How many ways can that happen? Well, if you look up here, how many of those have no girls in them? Just this one. Just one way for that to happen. And if you say, listen, I want to have 1 girl, by the way, in this case, or 1 boy, it makes no difference. How many 1 girl families are there up here? 1, 2, 3, 4 of those. That's right. And how many of these families up here have 2 girls in them? 1, 2, 3, 4, 5, 6. Oh, 6 of them do. Nice. And how many of them have 3 girls? 1, 2, 3, 4. And then how many of them have all girls? Oh, just the 1. Nice. And so when we do these combinations, I want you to kind of think about that in your head. It's not something we're making up. All right. Normally in class, I'd have you physically manipulate things around your desk, like grab this pen and this pen and this pen. And of these 3 things, how many ways can you choose 1 of them or 2 of them and stuff? And I think it's helpful for you to see that, but it's not the only way to see it. That's kind of neat. A gal, I'm gonna come back to this in a second. Gal that I teach this at a couple different levels. So I teach it at OIT as well, and so they're all engineers and software people and stuff there, and they've never seen probability stuff. So I was teaching this idea one time, and this lady, I was like looking over her shoulder, and I'm like, what on earth is she doing? And if you understand this, you'd be like, oh, that's pretty cool. I understood it, but I'm like, why are you doing that, weirdo? Like I knew what she was doing, but I didn't know why she was doing it. It was weirding me out. If you don't know what this is, just sit tight a minute and we'll explain that. Oops, try again, dummy. There you go. 1, 0, 0, 0. Okay, I should have went over here, I guess. 1, 0, 0, there we go. And then 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. There you go. 1, 1, 1, 1. Nice. So those numbers there are the numbers 0, through 15 in binary. Okay, binary meaning you on or off, or we could think of it as take it or leave it. And what she did was, is she said, listen, I'm going to count from 0 to 15 because she knew from enough of her computer stuff that she did that anytime you have a take it or leave it scenario, that's binary. And so in this case, she goes, well, if I just count to 15, that'd be all 16 of them. And then I'm going, yeah, I get that, lady. And she's like, well, look at it. She's like, here, these are all boys, if you will. I'm like, oh, that's pretty cool. And she's like, and here's one boy, two boys, or there's one boy situation. There's another one boy situation. Here's another one boy situation. And there's another one. I'm like, well, that's pretty cool. And then she's like, and then here's two, here's two, here's two, here's two, here's two, and here's two. There's 6 of them. I'm like, dude, that's crazy. And she's like, and here's 3, here's 3, here's 3, and here's 3. I'm like, that's crazy. And then she goes, and here is that one. And with all of them. And I said, that's pretty neat. And so I never thought about it like that way before. There's a lot of ways to come at this. Don't really care. The idea is when I look at this, order doesn't matter. I cannot tell this boy from this boy. Are you with me? It makes no difference to me. They're just boys or they're just girls, whatever they are. I can't tell them apart in that regard. Okay, so combinations have to do with the idea that when I look at them, I can't tell one from the other. In other words, these two girls could switch swap, and if they were my nieces, I could tell them apart. But I can't tell. If all I was talking about was, is it a girl or is it not a girl? That's all I care about. Then it wouldn't make any difference if they flip flop places because that's all it was about. So a couple things here. First of all, if you're asking someone like, what's the probability before you start having kids? It's probably you have 3 girls out of 4 kids. The first thing you have to ask yourself is, well, what's the denominator? Well, I'm having 4 kids. It's 2 times 2 times 2 times 2. It's 16 possible outcomes. And then the numerator would simply be, well, how many of these are 3 girl families? It's right here. Nice. So it's 4 out of 16, and you're off to the races. In fact, when you look at this, you could actually list it out like this, x and then p of x. So the things that could happen, you could have no girls, 1 girl, 2 girls, 3 girls, or 4 girls. All right, cool. There's a 1 in 16 chance of this happening. There's also a 1 in 16 chance of this happening. Probability of getting one of them is 4 out of 16. Probability of getting 3 girls is also 1 out of 16, or 4 out of 16 rather. And the probability of getting 2 girls is 6 out of 16. For a grand total of 16 out of 16 or 100%. That's only things that can happen there. Something that I think it never really hit me until a couple years ago. In terms of like the overarching aspect of this, the math I got, but in terms of like, oh, that's pretty neat, never hit me until a couple years ago. But if you think about this, if you are choosing, so if I said to you, listen, there's 10 people in the room, I'm gonna choose 3 of you to come with me and help me load some stuff around. What I'm really also doing is I'm also choosing 7 of you not to go. And that is why when you have A plus B equals N choose A will equal N choose B every single time, because whenever you're choosing 3 to go, you're choosing 7 to stay. If you're choosing 2 to be girls, you're choosing 2 to be boys, whatever it is, right? And it has to match up that way. That's why from a existential standpoint, it has to work. Mathematically, the formula says it has to work. But from an existential standpoint, well, I chose these 3 to be the winners. Okay, well, then that means I chose the rest of them to be losers. All right, cool. But it's going to happen the exact same way, okay? And so that's something to think about. We will be looking at this a little bit in the next week. We're going to be talking about expected value. And we're going to be looking at, hey, look, we can have all of these up here on top are all possible outcomes, okay? And then these are the probabilities of those outcomes. And we're going to be looking at this next week. And so kind of my plan today, again, is to go through this, the idea of combinations, permutations, kind of review a little of that, give a couple of examples of this in terms of how I'm going to use it. And then next week, we're going to move into expected value, what's called expectation. And we're going to be looking at some values for that. We'll be doing some simulation this next week as well. Unfortunately, I normally use Google Sheets for my simulation project. However, the thing that I normally use for Google Sheets, for whatever reason, got locked down this last term, and I don't know why, and I can't figure out why. I can still use it, but apparently other people cannot log in, and it's across the board. It's not a PCC thing. It's just across the board. That add-on's not working anymore for like add-on wise, and I don't really get why. So I am experimenting. We can always use Excel to do it, of course. The problem with Excel is, number one, is different versions of Excel. It's in there in slightly different locations, which is a giant pain in the keister. Number two, so I have to explain to you how to get there, which is kind of weird. Number two, and there's an extra step involved. Google Sheets is really nice. I discovered that completely by mistake. This one lady did it wrong, and she didn't follow the directions, and it still worked. I'm like, wait, that actually worked. And so it takes a little extra step out, which is kind of neat. But again, I will find a solution for that before next week. And anyway, I'll be modeling that in class next week, kind of talking about that as we go along. So that's something that's kind of coming and it's going to be fun to mess with. So another kind of place where this combinations come into play, and combinations, let's be honest, most things in my life, I would argue a lot of things in my life, probably more so combinations than permutations. There are things when order truly does matter, and in that case, you need a permutation. And again, if you're not 100% on board with what that is right now, make sure you watch the videos this week. Kind of a big deal. I just posted like 2 or 3 days ago, I think. These are, and I will, whenever I do this problem, I tell people, listen, they're either marbles or they're Skittles or they're M&Ms. And during the process of this problem, I will call them probably all three on accident. Because they're just little round things and you can't tell them apart by feel. So you just reach into this barrel of marbles or whatever they are and just grab some stuff. You're not gonna be able to tell them by feel what it is you're touching, okay? Ooh, it's a blue one, I can tell by feel. No, you can't, you weirdo. And so what happens here is we're gonna reach in and we're gonna select some of these M&Ms, whatever they are, and we're going to grab them, and then we're going to grab a handful at a time, okay? And so the other day on the test, there was a problem about drawing some cards, I believe, and someone said, well, you put it, you left it out, that's right, and then some of you were missing the problem because you didn't. No, it wasn't. How was that? Oh, it wasn't your test. It was another test. I'm sorry. I confused my two tests. Anyways, I teach another stats class. We're doing something similar to this. And the idea is that if I wanted to have an orange one or a red one, okay, and I want an orange one and a red one, I should say. It doesn't really matter what order they come out because let's be honest. If I take two M&Ms at a time, it wouldn't make any difference. I wouldn't know which one came into my hand first. And to be honest with you, I want a red one and an orange one. That's all I'm really interested in. So the order doesn't matter. Okay. If you think about it, when someone's dealing you cards, what's the first thing you do when you pick up your deck, when you pick up your hand of cards, someone dealt you? The first thing you do, everybody does it, unless you're weird. They put all the hearts here and all the, the spades here and so forth, and you organize them in your hand. It doesn't matter what order they were dealt to you. Now, sometimes it does. Like if you're playing Texas Hold'em, which I've watched it, I've never played it. Clearly, if that the first card that they drop on the table that's up or whatever, and it's like the first time around to bet, and you got nothing, you're probably not going to bet very heavily at that point, unless you're an idiot, or you're trying to snow everybody, I guess. And so, but had they dropped something on the table that gave you like a 3 of a kind right off the bat, that's going to change obviously because that if that card didn't drop till later in the hand, it was like the 5th card that dropped or whatever, you'd have been like, you probably would have folded on the second or the 3rd card or whatever. You're like, oh, I'm out. But had that one dropped first, it would have changed everything. Okay, so obviously order matters in some instances, but in a lot of cases, order doesn't matter at all. So in this case, what we're going to do is we're going to reach in, blindfolded obviously, and we're going to grab, I don't know, 4 M&M. Okay, and the question is this: what is the probability that we get 2 green, 1 red, and 1 blue? Now, I didn't write it right here, but it's implied that what do we have here? Is it or is it an and? Well, it's an and situation. It's implied. Okay. So the way to do this problem is we need to figure this out. We need to find out how many total M&Ms are in this box. So we got 5, 8, 11, 13, 17, 20, 23, 6, 29, 33, 35, 37, 39. 41. How about we just get rid of one of those? There we go, 40. There are 40 of them, and we are going to choose 4. You see that? And again, that's my denominator. This is how many ways it's possible to reach in there and select all the different ways I can get 4 different M&Ms out of this package. Okay, now I'll go ahead and open up Excel here, and I'll share that with you as well. Where's my Zoom? Open. Oh, fart. Oh yeah, stop sharing, start sharing. I hate I have to do that every time. All right, so let's find that denominator just for fun, shall we? So in Excel or Google Sheets, works the same way, equals combin. So you have 40 of them, and you're going to choose 4 of them. That's, sorry, kind of small writing. Let me make that bigger. So equals combin 40, comma 4. Okay. So again, that's how you find how many different combinations of 4 different M&Ms that you could find out of there. Okay. Now remember, these are not individual M&Ms in terms of like their names are Bob, Judy, and Steve or whatever. No, they're green M&Ms or they're red M&Ms. But her name's Judy. We don't care. She's a green M&M. That's all it is. Okay. So 91, 390 would be my denominator. Got to be a better way to do that. And let me scroll down a little ways, maybe. Come on, scroll. So 91, 390 would be my denominator. Now my numerator, I have a little trick for doing the numerators. Okay. What I like to do is I like to account for every single marble in the box. So for instance, there are 5 black marbles. I am going to choose 0 of them. Okay. There are 1, 2, 3, 4, 5, 6, 7, 8 dark blue ones. Oh, I should say dark blue. Dark blue. I guess it matters to have light blue. You with me? So there's 8 dark blues. Apparently, I'm choosing one of those. 1, 2, 3, 4, 5, 6, 7 reds, and I'm choosing one of those. 4 oranges. I'm not taking any of them. There's 12 green. I'm taking 2 of those, and there's 4 light blues, and I'm choosing none of those. Now, I like to account for all of them. You see, if you read books on, for instance, my brother-in-law, who I've not seen in 20-something years now, probably. The last time I saw him, he thinks he's smarter than he is. But he's reading this book about counting cards, and he's going to get rich and going to Vegas and counting cards. And I said, good luck, pal. But he was reading about all the different probabilities. And when you read about them, a lot of people will not include the 5 choose zeros and the 4 choose zeros. I think that's a mistake. I think once you understand what you're doing, it makes sense. But if you don't understand what you're doing, I think it's a very easy way to mess things up. Because if you think about this, if you look on the top, all the numbers on the left on top, if you add them up, they must add up to the numbers on the left on the bottom. In other words, there's 40 total marbles. And that's my kind of foolproof way of doing this. And then if you add up all the numbers on the right on top, they add up to the numbers on the right on the bottom. So 1 plus 1 plus 2 plus a bunch of zeros is 4. And that doesn't mean I'm completely right, but I'm probably right. I probably didn't screw this mess up too bad. Okay. Now, what is 5 choose 0? Well, again, I walk up to these 5 black marbles and say, I don't want any of you. Look, there's one way to do that. That is a fact. 5 choose 0. There's only one way to walk up and say, I don't want any of you. Go away. Okay. You can do it with a little more pizzazz or panache, but there's only really one way to do it. Okay. 8 choose 1. Hey, there's 8 dark blue marbles. I can choose this one or 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 this. There's 8 choices there. In other words, anything choose 1 is itself, which means this is also 7. 4 choose 0 is 1. 4 choose 0 is 1. This is the one that I'm going to have to use the calculator for, technically. I can probably do this one in my head. It's 66, but I'll go do it on the calculator just to make you happy. Okay. So I'm going to share with you here real quick. And it's not really a trick. It's just something that you learn over the years. Equals combin parentheses 12 comma 2. Boom. 66. Nice. And so then it's equals 7 times 8 times 66. Oops, what is that? Big dope. Why is there a T there? Oh, fart. All right, let's just don't get cute. 7 times 8 times 66. 3696. 3696. So I mean, while I'm here, I'm just going to go ahead and do this. Equals this guy divided by this guy, because that's my final answer. So there's a 4% chance that I will get what I'm looking for. One moment, please. So 3696 is my numerator. Come on. So 3696, and so my answer is roughly 4%. Okay. Question on the gist of that? We'll do a couple more of them, but that's kind of the big key there. I think this right here is the thing to always remember. I always include them all. There's really no reason to. I just have to do this one and this one and this one. Those are the ones I have to do. But I think even for me personally, when I'm doing it by myself, I've been doing this long enough that it helps me to remember that I accounted for everybody. I didn't miss anything. It's a double check that 5 and 8 and 7 and 4 and 12 and 4 all add up to 40. It's a nice, easy way for me to check myself before I screwed up. Here's a question. We will be doing this one a lot too going forward. What is the probability that I get at least one red out of 4? Remember, I'm still taking 4. So if I'm still taking 4, my denominator is still the same. Okay, which is still 40, choose 4. Now, you're like, there's a lot of ways to get one red. Oh yeah, you're not kidding, pal. You are not kidding. However, the easy way to think about this, the marbles in here they are red, and then there's a whole bunch of not reds. In fact, there's 7 reds in this bin, and there's 33 not reds. Okay. So when I look at this, probability of at least one. Okay. We will use that a ton in statistics, and so I just want to mention this again. The probability of at least one is equal to, or I'm sorry, plus the probability of, well, let's put it this way. Yeah, that's right. Well, and remember, this is probability that x is greater than or equal to 1. That's what at least 1 means. And so then, of course, that's probably the x is, the opposite of that is probably the x is less than 1. What's the probability that x is less than 1? Well, probability of 0. I mean, that's all it can be, right? In the case of this, can't get -5, and you can't get 0.2 reds. That's weird. So the next thing down from 1 red is 0 reds. And you know, the whole thing is this, that has to add up to 100%. It has to add up to 100%. Well, there are a lot of ways to do this. And I don't want to solve for them all. That's way too much work. Okay, so instead, what I'm going to do is a little bit of algebra. This is the answer that I want, and to get it, I'm going to do 1 minus the probability of 0. That's what I'm going to do. And so what I'm going to do is I'm going to say this is the only thing that makes me unhappy. It's the only thing. So if that's the only thing that makes me unhappy, I'm just going to subtract it from 100%. Everything else then must make me happy, apparently. Okay. That is a big deal in statistics. We will do that a ton. So of the 7 reds, I'm going to find this. I'm going to find what's probably I get none of them. And then the other 33, I'm going to choose 4 of. Okay. Well, of course, this is 1. I don't know what this other answer is. I'll go find it and write it down. Bear with me. I'll go do it on the computer here real quick. Equals. What the hell? Equals. Bin 33, 4. Boom. Boom. What just happened? Oh, I put a comma in there, you dope. Oh, Oh, I see what happened. Somehow or another, I ended up, when I did that, I did not put a, that's embarrassing. Oh, for God's sake. There we go. 4920. Okay, so this is 40,920. Okay, and when you do this, 40,000 divided by 91,000, I mean, anybody can do the math in their head on that one, just about, equals, or get a pretty good view of it, that's gonna be about 44% or thereabouts. That divided by that is about 44.7%. Okay, 44%. Now you're like, well, wait, what does that mean? This is the probability I get 0 reds. I wanted at least 1 red. I know, I'm not there yet. So 1 minus 44% is equal to 56%. This is the idea of using what is called the complement or complementary events, right? That is the opposite. So we will use that a ton in statistics, like a ton. If you take stats 243 and 244, in 244, you'll be doing it all the time, okay? Because the computer and the calculators, they only give you what's called the Cdf function. And you know what that means now, and that's totally fine. It gives you the probability that x is less than or equal to a particular value. Well, if I want more than that, then I'm going to take 1 minus whatever the computer gave me to go find the rest of it. I mean, you do that a ton. And if you get a teacher who's like some old relic from 1983 or something like I had, they will teach you, oh, we must use these books, these tables in the books. Well, that's cool. The table in the books was someone did the calculator method and basically wrote them down, but okay, cool. They are written in a certain way that they only give probably x is less than or equal to a particular value. So if you want above that value, you're going to do this whole idea of 1 minus it. You use it a ton. And so that's something that we will continue to do as time goes on. Okay. The same thing could have been done back here on this one. What is the probability of getting at least 1 girl? All right, I don't know. Let's find out. Well, I don't really know. Well, let's take that out of 8 kids. Like you're gonna have 8 kids. That's yes, it's a fact. That's my brother's family. They're gonna have 8 kids. Okay, cool. What's the probability to have at least 1 girl? Well, it's almost 100%. Think about that. Because the only way they could have no girls is if they had 8 boys. Well, what's the probability of that? I don't know, Jay, but it's not good. You're right, it's not good. It's very, 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 very tiny chance of that happening. And in fact, I'm going to show you what it is. Remember, our denominator is 2 to the 8th power, or 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 256. Okay, so I don't know this problem, but I do know that it's equal to 1 minus the probability of getting 0 girls, which I know intuitively is very small. And so 1 minus a very small number is going to be like, 99% chance that I have at least 1 girl. So again, that was going to be something like this, 1 minus. Now, in the denominator, it's going to be, as I say, 2 to the 8th power, or 2 times 2 times 2 times 2, which is 256. In the numerator, well, check this out. What is 8 kids choose 0 of them? Well, anything choose 0 is always 1. There's only one way to pull that off. And so the final answer is going to be 255 out of 256, which, look, I'm no math teacher, but I feel like that's a pretty big number probability-wise. 99.6%. Nice. In other words, you're almost guaranteed, if you have 8 kids, you're almost guaranteed to have at least one girl. Now, I will say this. You're like, honey, we got to try again because we have to have a girl this time. Wrong. If you have 7 boys so far and you're like, this next one, I know it's going to be a girl. I know it is. Nah, it's still 50-50. No. No, this is saying before you start, okay? Before you begin having your 8 children, there's a 99.6% chance that one of these 8 kids will be a girl. At least one of them will be a girl. Okay, that's a big deal. However, as time goes along, you're down the rabbit hole a ways. Okay, you've already got 7 boys. If you really don't want to have 8 boys, you probably should stop now. Okay, but it's 50-50 either way. It's not you gotta go. All right. I knew a guy once. They kept trying until they had a girl, and they kept saying, "It's got to be this one." I'm like, dude, no. And every time we talk to them, I didn't say a whole lot. I'm like, okay. And we go home, like, dude, they're nuts. And they kept having kids, and finally they stopped. And they did have a girl, but it was like the seventh kid, sixth or seventh kid. They finally had one. And I'm like, wow, I think I would have quit before that, but that's whatever. All right. But again, what you're saying is each time is independent of the previous one. Okay. What they were saying is that because of this, the next one has to be. Nope, doesn't work that way. So unless you believe that one Family Guy episode when Stewie shrinks himself down and goes and fights inside of what's the dad's name? Don't want to carry on Family Guy. Anyways, and that's silly, right? That doesn't happen that way. Because this happens doesn't mean the next thing has to happen, right? They are completely independent events. All right. I am typically fairly logical, and I don't try to mix my math with my emotions and so forth. However, I was quite positive that I would have a girl because I'm like the seventh firstborn son in a row, firstborn son of a firstborn son of a firstborn son of, going back at least 7 generations. And my grandma did a bunch of research back in the day. And we all were farmers, and I was too for a few years after college, and then I had to quit. And so my son's gonna be the firstborn son, or my kid would be the first kid that wasn't gonna get to farm. And so I was convinced it was gonna be a girl. Well, it wasn't. And then my second kid, I thought, well, whatever. So then I had 2 boys, and then we stopped. My brother, who was always the favorite child, whatever, he had a girl, and then a girl, and then a girl. And I figured, well, that figures because, he's mom's favorite. Mom always wanted a girl. There you go. Anyway, so whatever. So then they get pregnant, they have another kid. And I'm like, oh, this will be another girl. Nope, at a boy. I'm like, oh, it doesn't really surprise me. It'd be odd, actually, they'd have 4 girls, right? When it's all said and done, it'd be a 1 in 16 chance of having all 4 girls. It's very small. And again, I know intuitively that the odds, the probability is exactly the same each time. It's right at 50%. Now, they had another kid. That was another girl. Or another boy, I mean. So then they had another kid. It's another boy. And when it's all said and done, they had this. Whenever I tell people this, they're like, oh my God, that's so weird. I'm like, what do you mean it's weird? And they're like, some people will say, well, that's so weird. It is kind of weird. There was 3 girls and then 5 boys. But if you think about it, 3 girls out of 8 kids is pretty darn normal. Okay, that's pretty normal. This specific pattern is pretty weird. In fact, this specific pattern is just every bit as weird as this. Think about that. It's like calling your phone before you start. Not only am I saying, I'm not saying I'm gonna have all 8 boys. I'm specifically saying I'm gonna have 3 girls and then 5 boys. Question. So when you do that, when you think about these situations, this is one specific weird situation that could have happened. What is 8 choose 3? Okay. So my brother, if I told him this, he would have said, he probably wouldn't have paid any attention anyways. I didn't blame him. I'm gonna do it on the calculator here. 8,3. There are 56 ways for this to happen. Okay, 56 ways. This is one of them. This would have been another way. That would be another way. There's 56 ways to reorder those 3 girls. Okay, but they specifically ended up with that one. So people, when they look at me, they're like, some people say, oh, that's weird, Jay, and it is a little weird. There's 56 out of 256 chances. This is the probability of 3 girls. Notice that in this situation, out of 8, obviously, kids, this one here this is no regards to order. They could be in any order. For my brother's family going into it, there is one way for this specific order to show up out of 256. And so that's why people look at this one and they're like, oh, that's weird. I don't know why it's weird. It is one aspect of things that happen, okay? It is every bit as odd or weird as having 8 girls in a row. It is every bit as weird as having 4 girls and 4 boys, whatever it is, it's all the same. Every one of them is weird in its own right. However, if someone said to you, hey, what's probably to have 3 girls out of 8 kids? Well, there's 56 out of 256 ways to pull that off, okay? And in fact, one more thing I just want to mention on this, and kind of riffing on this guy here a little bit more. If you have 8 kids, these are the things that could happen girl-wise. There's 9 outcomes. People always forget about that you could have 0. So 0 through 8. Well, there's 1 out of 256 of these on either end. Something else I want you to always pay attention to is completely symmetric in these situations. So 3, which is this one here, has to be symmetric to this one here. Because if you had 3 girls, you had 5 of the other. There you go, escape. What about 8 choose 1? Well, what is 8 choose 1? Well, 8 choose 1, or anything choose 1, is always 8. So this one is 8 out of 256. That means this one is as well. Okay. I'm going to do this one here real quick. What is 8 choose 2? You'll see this in the video this week. It's 8 factorial over 8 minus 6. Oh, I'm sorry, 8 minus 2 factorial. Sorry about that. I did the 6 in my head. Times 2 factorial, which is 8 times 7 times 6 times 5. No, you won't have to do this by hand. I just show it to you because I think it helps sell the bit a little bit. This is 6 factorial. And then 2 factorials are the 2 times 1. These cancel off. 2 goes into 8 4 times, so it's just 28. By the way, on this one here, notice that on the denominator, on this one, 8 choose 2 and 8 choose 6 would have come out the same, because we would have ended up with 8 minus 6, which is 2, and then we would end up with 6 here. So instead of being 6 factorial times 2 factorial, we get 2 factorial times 6 factorial, but it would have been the same answer. I'm going to go ahead and add those up right now. So far, we've got 1 plus 8 plus 28 plus 56 plus 56 plus 28 plus 8 plus 1. So far, we've accounted for 186 outcomes so far. So what does that say about this last guy here? The rest of the outcomes, the rest of the 256 had better be right there, which means 70, I guess. Okay. If you think about that, does that make sense? See, I'll bust it out of my calculator and let you know what it is. What is, oh shoot. What is 8 choose 4? 70, yay. Again, this makes sense. What is the most common number of girls you're going to have out of 8 kids? 4 of them. That makes sense. Half of them. It is, if you will, the expected amount. Okay. We're going to be talking about, again, that in this next week. In the next week's videos, we're going to be talking about expected value, and that's going to come into play as well in this regard. It's only the expected value because we're looking at a 50-50 shot here, right? Later on, we have other aspects, like there's, I don't know, like rolling the dice, for instance. There's 6 outcomes on the dice. Then each one of them is 1/6. So the expected value will be different, obviously, on that than it would be in the case of, you know, this just some kind of a deal thing. Okay. That's the kind of thing we're going to be talking about this week. So in the combinations and permutations videos, kind of think about that. I guess the things I want to leave you with today are the probability of at least 1 is equal to 1 minus the probability of 0. That's a big deal. I want you to be stuck in your head. I also want you to remember, we talked about this early on in one of the early videos. Probability of rain. What's the complement of probability of rain? Well, it's plus probability of not rain has to equal 100%. But remember, this right here incorporates a ton of stuff. It's not just sunny and 85. It's overcast. It's snowing. It's, you know, it's everything but rain. Okay, and so, but really, you just lump it into not rain. Same thing is true for the M&Ms. I got red M&Ms. I got not red M&Ms. Okay, winners and losers, and whatever it is, I can lump everybody in to the opposite of that. Okay, so that's kind of a big deal. The idea of those, the idea of that M&M pod over there. You know, go back and look at wherever it went. Is this it? Yes. Go back and look at this idea. Kind of keep that in your head. I think that's helpful for a lot of people. Those are some of the biggies. Something else that I talked about in the video a little bit, but here's another example of it. This was a license plate, and you had, I don't know, 3 letters, 3 numbers. Yeah, then this would be, how many options do you have? Well, you have 26 choices for the first number. How many choices do you have for the second number? Well, a lot of people will say 25, but that's not true, because you can have repeats. You get A. So there's still 26 choices, and then 26 choices. Okay? And then, so you need 3 letters and you need 3 numbers. So again, multiply. And then you have 10 times 10 times 10. A lot of people forget 0. That's 0 is one of our favorite numbers. So the numbers at 0 to 9, that's 10 of them. And when you multiply that out, you get, I should know this off the top of my head. I answered this problem enough. 17576, 17576. Dos, tres, I think. Is that right? Yeah, perfect. That's it. This is how many license plates there are that follow this pattern. Okay, and so in essence, like in the state of Oregon, you'd never run out of license plate numbers. Right? You just wouldn't. Would it matter if I put the letters and the numbers in the opposite place? That would make a big difference. Yes. How many would you have in that case? You'd have times 2, right? Okay. Why is that? Because the number could come first or second. You have 2 choices for that. So it's 2 times 26 times 26 times 26 times 10 times 10. Okay. Just something to think about. Let's see here. Oh, also, phone numbers, same way. 1, 2, 3. 1, 2, 3, 4. Okay. For if you had this phone number, you're in St. Helens. Good for, oops, no, you're not. Now you are. You're in St. Helens. If these numbers are the same, there are 10,000 phone numbers that are available for this prefix in this area code. Okay. But then you're like, well, we ran out of prefixes. So what do? All right. So you add a second prefix, let's say. Well, this is your second prefix. Then what do you got? Now all of a sudden you've got 20,000 phone numbers. Okay, by doubling the number of prefixes that you had. And again, this is, back in the day, you only had, 1 prefix or 2 or 4 or whatever in a town. As a kid, Walla Walla was like this. It was 509, and it was always 529, I guess, initially. And then they came out with 525, and then 522, and that was probably before cell phones came out. Okay, that was like right when cell phones were just starting to become a thing. And then cell phones hit. So now not only do you have a phone number at home, and maybe you have 2 or 3 at your business, now you get the cell phones and fax numbers and everything else, and it exploded after that. And so when I was a kid, and I grew up in Washington, well, can I draw Washington? I can't know if I can draw Washington anymore. Anyways, when I was a kid, it was always the 360 on this side of the state and 509 on this side of the state. Oops. And now they've added a zillion more prefixes up there because obviously they have a ton of people. And down here we have, what, 3 now? And so obviously that just keeps exploding. Every time you do that, though, what do you add? Well, initially for these 3, okay, you have 10 times 10 times 10 times 10 times 10 times 10 times 10, which is 10 to the 7th power, which is 10 million phone numbers. Okay, that's 10 million possible phone numbers for 1 area code. So you add another area code, now all of a sudden you double the amount of phone numbers that are available. Okay, and so that is why they've done all that sort of thing. Okay, so it gives you more options, gives you more regions, gives you more ideas of how to do things, obviously. And of course, everybody's got multiple phones nowadays, so obviously that's why they have to keep addressing the whole thing. In reality, there's some area codes that we'll never use. 555 is not allowable. So you're like, oh, but Jay, isn't that really minus 20,000 or minus 10,000 because you can't use this guy? Yeah, technically you're right. Okay. And there's a few others. I think you can't have 000. So there's a few others that they've said that they're not allowed to use this one. That's cool. But in reality, there's a lot of phone numbers that are possible out there. So this is the idea. It's 10 million, okay, possible phone numbers with 1 area code with a few provisos. Okay, maybe you're not allowed to have all zeros. Maybe you're not allowed to have 555 for a prefix, and so on and so on. Okay, So there's a few like that, little provisos that they have. I'm not up 100% on all their little possibilities. Same thing's true with zip codes. You know, maybe yours is this, whatever. Then you realize they added the 4 digits on the end of that. Okay. Well, why is that? Because here, this is 10 to the 5th power. That's only 100,000 zip codes. Okay, which one would think that'd be enough, but it's not enough. Okay. And so, like, you know, a small town, you've got a zip code. That's nice. Hardly anybody lives in that zip code. That's true. In a big city, that one zip code, but you need to get a little closer because, yeah, it may encompass the entire or part of the city, but it's a huge city. And so that's a huge part of the city. So they might chop it up into smaller subsections of this guy to make sure it gets to the right post office in that zip code. Okay. And so it gives you more freedom to work there. Okay? Back in the day when we used to have this in class and I had more freedom to work, I would always kind of come from here. I'd venture off into do some coding. So we talk about UPC codes and things like that. Unfortunately, when a few years ago they said we have to do logic and a couple other things, something had to go, and so that's what ended up going. It's unfortunate because I kind of liked talking about that. People it's kind of fun to talk about. You know, hey, we got all these numbers. You know, what is the point of them? And then also, you know, what does it form the background of? So, for instance, when you're talking about digital communications, like we're having a conversation right here. In our conversations, I talk, it goes in, it gets transmitted into zeros and ones or whatever, it gets sent out on somewhere, and then, you know, you listen to it. It's nice that it comes out to be something good and it's understood. It's understood to be, you know, what it is. And so then if there's any mistakes, the codes, they've developed these codes behind the scenes to actually correct the mistakes. And so it's rare that there's actually a mistake that you actually are perceive, because it's usually fixed behind the scenes. And it's all about probability. And it's kind of neat how it works behind the scenes. But again, there's just no room to talk about that anymore. So that kind of went by the wayside. So that's kind of the game. Again, it's pretty clear. This is all hinged on the idea of and. So whenever we're doing this, and remember, it means multiply when it comes to probability. Okay. And so I have to have a first number and a second number and a third number and a fourth number and a fifth number. So when you're doing the zip codes, just need one of these 10 or one of those 10 numbers on each of those 5 deals. So 10 to the 5th power. Okay. I think you'll find most of the problems this week in the lesson to be fairly straightforward-ish. You may run into 1 or 2 that make you kind of scratch your head. Again, always contact me if you have questions. Hopefully that kind of lays things out for us. And again, this next week, expected value is one of the topics that really affects our daily life. Okay. It kind of affects our daily lives behind the scenes. Sometimes you don't think about it. But something that we're going to talk about is the idea of insurance. And whether you are in favor of Obamacare or not, one of the concepts is, you know, the people who have pre-existing conditions. Okay. Well, for instance, if you have all these problems and you take out a life insurance policy or medical policy or any other policy like that, or let's say you're a bad driver, you've been in 87 accidents, you get 45 tickets, and they really still have not taken your car away from you yet. The insurance company is going to be more likely to have to pay on you. Okay. And because they're more likely to have to pay on you, they're going to have to charge you more to cover that. Okay. And so if you are a healthy adult in your like late 20s, early 30s, and you don't drive race cars and you don't smoke and you don't jump out of airplanes for a living and so on and so on and so on, you're just a normal run-of-the-mill person in good health, you have a very cheap insurance policy. Okay. And I don't really care what kind of insurance it is. That right there, you're in a sweet spot. But if you're like in your late 60s, like in your mid 60s, and you're like, I'm going to take out this health insurance, this life insurance policy, and I'm a 400-pounder, I'm diabetic, I've got this, I've got high blood pressure, I've had a stroke, I've got and you think I'm exaggerating, maybe just a little bit, but that's basically describing my dad's friend who came to buy insurance from him one time. And my dad was upset because how am I going to tell him that they're going to try to charge him a fortune to insurance? Well, it turns out they wouldn't do it at all. It's like like trying to get someone to bet with you on something. Like, okay, so here's the deal: the Seahawks are coming to town. They're going to play St. Helens. Would you bet on this? Would you bet on the St. Helens Lions? To do what? To lose by 1 million? No, to win or whatever. No one's going to take that bet. Nobody's going to take that bet. It's not going to happen. I don't care. The worst team in the NFL comes play a high school team. They're losing. The high school team's losing every time. You will not get anyone to take your money, take your bet on that. It's not going to happen. Now, horse races may be a little different. Like this old nag, yeah, I'm going to bet on her. She's not going to win. Yeah, she's 1,000,000 to 1 long shot. Yeah, but I'll throw $2 on her. That's no big deal. Probably not going to win. If they did, they'd win big. But no one is going to bet. They're not going to take the bet at all. And that's the same thing that happened with insurance. Okay. And so things like when you go to buy your premium for your insurance, like, why is my premium so high? Because the company expects to pay out on you because of all of your bad driving habits over the years. That's why. Why is my premium like this? Why is all this? Well, because of this. That's why it happens. And I'm going to show you some other stuff that you do just automatically behind the scenes. That's what you all do. Why did you make this decision? Because I expect this to happen. Oh, so that's why you did it. Because a lot of things we do in life are inherently based on probability. Okay, from past experiences, you collect data, you look at that data, and then you make a decision based on that data. And it's all about, what do you expect to happen? Can you be wrong? Of course you can be wrong. And in the case of, if you could be wrong like 50% of the time or 40% of the time, in those situations, if you were wrong, it's unlikely that you're going to be wrong. But if you were wrong, what I want to say on that, it's unlikely that you'd be that wrong. But if you were wrong, you probably didn't bet a ton of money on it, or bet a ton of your time or whatever on it. But in a situation where the chances of you being wrong is like 5% or something, you've probably gone all in. And you're probably shocked if it does that, because again, you based your decision based on previous data going forward. Yeah, that's about all I got today. I noticed a couple people just showed up later-ish, and I'm wondering, is there something that was different in the invite or something this week? I recorded it, so thanks to Ross. So it's recorded. I'll just put it up. But any questions from the homework at all you want to see or anything? Anything question about? Anyone? Nobody? So again, your tests, I thought for the most part pretty good. Try to make comments on all of them that was on there. I think that's probably next time when I do them, I'll have I was telling Ross early on, I graded your guys by typing in your comments. I think on the next one, I'm just going to write them on a sheet of paper like I did for one of my other classes, and then scan the papers to you. I just think that's maybe a little easier for me to go. But again, next week, there's going to be a video, and I'll have that up probably later today or tomorrow about expected value, and we'll kind of go from there and kind of see where we go. I may do a little extra fill-in video this week as well. In regards to, as I was telling him earlier, I normally use Google Sheets for the simulation. I've been doing it for the last 4 or 5 years that way, but the program that I normally use apparently is quit working for some people. Works for me just fine, but I can't get people to load it anymore. And so I'm probably going to go back to using Excel. It's not quite as handy, but I will probably put up a short video for that this week too. And I'll ask you to reply to me that yes, you can get into it in Excel, or no, you can't get into it in Excel. And if that happens, then we'll work around that as well. What's going on here? Oh, I'm sorry, Hilario. That sucks. Wonder how that happened. Well, probably Jay's an idiot by how that happened. I don't understand. Anyway, if you have any questions, let me know right now. Otherwise, like I said, I recorded this. I'll put it up. You didn't miss a ton. I did some examples with combinations and the idea of counting principles and that sort of thing. So, geez, I don't know. That's terrible. No, I apologize for that. That's no good. And if you need to talk to me, if you want to do a little special, if you want to hang out afterwards and talk a little bit, that's cool too. If you want, Larry, let's work around that. Anybody else? Questions, comments? Nope.
Jay, do you have an average for the midterm?
An average. For you mean the whole class?
Yeah.
I don't normally do that. I'll probably figure it out though. You want to see where you are there? You cannot minimize the Zoom when you're recording the meeting. Oh, okay. All right. I don't know. Let's see if I can find it.
If it's hard, you don't have to. I was just curious if you had it handy.
No, I don't normally look at it. I don't really care. Averages, especially in a smaller class like this one, is the smaller class because I think only 10 of you took it, and some people dropped in the class, I guess, and then I had a couple other people that took it late. One person that took it late because of some issues and whatever, and that's fine. I haven't graded that one yet. So small averages, you never know. It's not that I don't get it doesn't do anything for me, but that way I guess. And when I look at it, I just oh, okay. But I just know looking everybody else, looking over them, I felt really good about them. So we had, yeah, the average would have been probably 75-ish, 78, probably 78. No, actually, it's better than that. No, because there's 100 there. No, it's well better than that. So I'll just add it up here real quick. It won't kill me. One moment, please. So, oh, get over here. All right, so 188, 198, 81. Oops. Yeah, 85 actually, for what it's worth. I don't know. Anyway, yeah, like I say, it's is what it is, I guess. Hey, greetings. So, as I was just telling, these guys here. Apparently, Hilario mentioned that the meeting said it started at 9. I don't know how that happened, so I apologize. I did record it. So I'll post that. But if you have any questions, particularly hang out, that's cool. Otherwise, yeah. So Ross wanted to know what the average was on the test. So it was 85, if that matters. I don't know. But I don't know. I don't get too hung up on averages. I just look at it more like, first of all, I've been doing this a long time, so I know what I'm teaching and what's on the thing, so I don't get too concerned about it. The first time I teach a class, I get a little concerned. Did I make sure I covered everything right? Was the test appropriate? Now that I know what I'm doing, I don't. I've been doing this quite a long time. I don't see that as big a deal anymore. So I don't know. If that makes you happy, I guess. I thought it was, but again, small class size, that really skews the data, as we've talked about. Had one or two of you done exceedingly poor, that really would have dragged my average down. and had one or two of you done, 2 of you did really well. 3 of you did really well, and that obviously bumped us up. Yeah, whatever. Anyway, if you have any questions, you want to hang out, stay around for a few minutes. Otherwise, I'll see you next week. Again, make sure you're on the lookout. I'll probably send the link out via an email. It'll be a try this on your Excel and make sure you can do it. And or I will send out a Google solution. As I say, what I've been doing on Google Sheets is not working right now, so I'm trying to find a workaround. So I will have that later this week. I need you to try it. Yes, it works. No, it doesn't. So that I have clear cut. I'm going to do it this way or that way for my next project. So, okay. Otherwise, have a nice day. We'll see you later.
Thanks.
And again, I apologize for those of you that came in late. All right. Any questions, Kip?
I don't think so. I was just kind of, I was thinking about the assignment that's due tomorrow and considering whether.
Which one?
The financial assignment.
Sure.
I was just curious if there needed to be different amounts that a house costs on them. I realized I used the same price.
Yeah, that's
over
what I
and over
wanted.
again.
So that's what you were supposed to do. You're supposed to riff on the same house.
Great.
And then what would have happened had I done this? If I refinance, what happens if I paid extra? What happens if I had put a bigger down payment down? You know, whatever. Those are the things I want you to fool with. I don't want you to fool with a bunch of different houses.
Okay.
I want you one house and just different things with that one house.
Great. Well, I did that.
Excellent.
Okay. Thanks.
Yep. All right. Sorry about the mix up. That's my fault, I guess. There. I don't know what happened. So.
It's all right.
All right. See you later.
Bye.